Good morning, respected examiner Dr. Fasi and my supervisor Dr. Shamim. My name is Nurul Afiqah Insyirah binti Abu, student ID 22002020. Today I will present my FYP proposal titled LLM Assisted Bug Report Tracking and Prioritization System for Software Quality Management. This project focuses on using large language models or LLMs to automate the process of managing software bug reports, making software maintenance faster and more efficient. This presentation consists of 9 sections. First, I will introduce the project background. Then, I will discuss the literature review, problem statement, objectives, scope, methodology and tools, project timeline, testing and validation, and finally, the conclusion and future. Now, I will begin with the introduction and background of this project. Today, software companies receive hundreds or even thousands of bug reports through platforms such as GitHub Issues and Jira. Currently, developers have to manually read every bug report before deciding its category and priority. This manual process is slow, repetitive, and sometimes inconsistent because different developers may classify the same bug differently. Large language models are able to understand the meaning of natural language instead of only looking at keywords. Because of this ability, LLMs can automatically classify bug reports, detect duplicate reports, and predict which bugs should be fixed first. That is why I propose using an LLM to assist the bug tracking process. This problem is important for several reasons. First, there are more than 1 million bug reports stored in the Eclipse Bugzilla repository. Second, many open source projects receive hundreds of new bug reports every day. Despite this large number of reports, many development teams still review bug reports manually. I choose this topic because research shows developers spend a significant amount of time sorting bug reports instead of actually fixing the software. Since recent LLM technology can understand the context and meaning of text, it has a strong potential to automate this process and improve software quality. This project provides 4 main contributions. First, it makes bug tracking faster and more consistent because the LLM classifies reports based on meaning instead of human judgment. Second, it can identify duplicate bug reports even if they use different wording. Third, this project compares the performance of LLMs with traditional machine learning models such as naive-Bayes, SVM, and random forest. Finally, although this project uses GitHub, the same framework can also be applied to other issue tracking systems like Jira and Bugzilla. Next, I will discuss the literature review. I reviewed several recent studies related to bug tracking. Most previous studies only focus on one task. For example, some studies only perform bug classification, while others only focus on duplicate detection or prioritization. Some studies also only provide surveys or dataset without developing a complete working system. Therefore, current research is still fragmented, and there is no single system that integrates all tracking tasks while comparing LLMs with traditional machine learning. From the literature review, I identify 4 research gaps. First, bug classification is inconsistent because it depends on human judgment. Second, traditional methods cannot detect duplicate reports that use different wording. Third, most previous studies only focus on one tracking task. Lastly, very few studies compare modern LLMs directly with traditional machine learning methods for bug tracking. These research gaps motivate my proposed system. To solve these problems, I propose an integrated LLM-assisted system. First, the LLM performs severity classification based on the meaning of the bug report. Second, phase is used to detect duplicate bug reports through semantic similarity. Third, the system generates a priority score so developers know which bug shall be fixed first. Finally, the complete pipeline will be compared with traditional machine learning models to evaluate its effectiveness. Next is the problem statement. The main problem is that software teams still rely heavily on manual bug tracking. This process is time-consuming and may lead to incorrect classification and delay prioritization. Previous research has applied traditional machine learning methods such as PFIDF, naive-Bayes, and SVM. However, these methods mainly rely on keywords and usually solve only one task. Therefore, this project proposed an integrated LLM-assisted system that combines classification, duplicate detection, and priority ranking into one complete pipeline. Now, I will present the objective. There are three objectives in this project. The first objective is to investigate the current bug tracking process and identify the users and project scope. The second objective is to design and develop an LLM-based bug tracking system. The third objective is to evaluate the proposed system and compare its performance with traditional machine learning models using evaluation metrics such as accuracy, precision, recall, and F1 score. Next is the project scope. This project focuses on software bug reports collected from GitHub. The main users are software developers, QA engineers, and project managers. The system includes three main functions. First, bug classification, then duplicate detection, and lastly, priority ranking. GitHub Issues API will provide live bug reports, while the Streamlit dashboard will display the result to users. Now, I will explain the methodology. The project follows 6 phases. First, bug reports are collected from GitHub issues and the Eclipse dataset. Second, the text is cleaned through pre-processing. Third, the LLM classifies the bug severity. Fourth, phase detects duplicate reports. Fifth, the system predicts the priority score. Finally, the results are evaluated and displayed on a Streamlit dashboard. I use a pre-trained Hugging Face model instead of training a new LLM because it saves development time and computing resources. The project is developed in separate modules so that each model can be tested individually before integration. GitHub Issues was selected because it provides an open API and real bug reports, while the Eclipse Bugzilla dataset provides labeled historical data for training and evaluation. I selected the incremental model as the software development methodology. Each model, such as classification, duplicate detection, priority prediction, and dashboard, is developed separately. This reduces development risk and allows problems to be detected earlier before integrating the whole system. The backend is developed using Python and Fast API. The LLM comes from Hugging Face transformers, while Fast performs semantic similarity search. For comparison, traditional machine learning models include naive-Bayes, SVM, and random forest using scikit-learn. The database uses SQL-lib, and the user interface is built with Streamlit. Development tools include VS Code, Postman, and Git. This diagram shows how the system works. First, a new bug report is submitted. The report is sent to the Fast API backend. The backend cleans the text, performs LLM classification, checks for duplicates using Face, and calculates the priority score. The results are stored in SQLite and finally displayed on the Streamlit dashboard. Next is the project timeline. For FYP 1, the main activities include proposal preparation, literature review, identifying research gaps, selecting the technology stack, designing the system architecture, collecting datasets, and developing the initial classification prototype. For FYP 2, I will complete the duplicate detection module, priority prediction, integrate all modules, develop the Streamlit dashboard, perform benchmarking against traditional machine learning, conduct testing, and prepare the final thesis and presentation. Now, I will explain the testing plan. The project includes 4 types of testing. Unit testing checks each module individually. Integration testing ensures all modules work together correctly. Performance testing measures system response time. Finally, user evaluation measures classification performance using accuracy, precision, recall, F1 score while comparing the proposed LLM system with naive-Bayes, SVM, and random forest. Finally, I will conclude my presentation. In conclusion, this project proposed an LLM-assisted bug report tracking and prioritization system to automate bug classification, duplicate detection, and priority ranking. The expected outcome is to reduce manual work, improve classification, consistency, and help developers identify critical bugs faster. This project also aims to demonstrate whether LLMs perform better than traditional machine learning models in software bug tracking. Lastly, I will discuss the future work. In FYP 2, I plan to complete the duplicate detection and priority scoring models. I will also finalize the stream dashboard and conduct usability testing with users. Finally, I will perform a complete benchmarking evaluation against naive-Bayes, SVM, and random forest using real experimental results. That's all for me. Thank you.